So today we are going to be looking at functions and function notation. So our learning targets to be able to determine if a table of ordered pairs represents a functions, be able to write an equation in function notation given its words, be able to complete a table of values for a given function, and be able to evaluate a function at a given value or algebraic expression. So what exactly is a function? It's a rule that assigns each input value x with exactly one output element f of x. So it's basically the x's cannot repeat for its function. So if I have a table of values here, such as my x and my y here representing f of x, same thing. So if I have 2 paired with 3, 3 paired with 5, 4 paired with 9, and also 3 paired with 4, seeing here how your x values are repeating, you've got 3 here with 4, and you've got a 3 here with 5. So the 3 there is repeating there, so this would be considered not a function. A lot of times it's easier to understand something if we say what it's not. So basically your x's cannot repeat for a function. So looking at this first example, is this a function or not? So you're basically looking to see if the x's repeat. So looking here, you've got 1 paired with 2, 1 paired with 3, 1 paired with 4, and 1 paired with 5. So this is not a function. And it says, if it's not a function, explain your answers. And I'm going to say, because the x's repeat. Let's look at another example here. Is this a function? 1 is paired with 7, 2 is paired with 8, 3 is paired with 9, and 4 is paired with 10. Is that a function? Yes, that's a function. Notice the x values do not repeat there. We don't have to explain our answer when we say yes, it's a function. Only if it's not. And then our example 3 there, so letter C there, is this a function? 1 is paired with 2, 2 is paired with 2, 3 is paired with 2, and 4 is paired with 2. Now remember, if it's a function, the x's don't repeat. So the x's are not repeating here. It's not another 1 in the x column here, or another 2 in the x column, or another 3 with another ordered pair y, or a 4 with another y value. The y's are repeating, but the x values are not repeating. So it's okay for the y's to repeat, it's just the x's cannot repeat. So yes, this is a function. And then let's start looking at our next learning target here. So we're going to write these words here. We're going to take those and we're going to put that in function notation. So we're going to write it as a function here. So f of x equals, the statement here is the square. So we're talking about, we're going to square the x value and then add 9 to that. So when we square the x, it's x squared and then add 9, so plus 9. So squaring something needs to take it to the second power, and then adding 9, that would be plus 9. So writing this in function notation for letter B here, f of x equals, it says to multiply by 2 and then subtract 3. So we're going to multiply the x by 2, so that's 2x, and then subtract 3, so minus 3. The third one here, letter C here, says to add 3, so we're going to add 3 to x. And then we're going to go ahead and take the square root of that. So I'm going to take the square root of that. So we added 3 to x and then took the square root of that. Example 3 here, we're going to start here looking at the next learning target here. So we're going to complete the table here. So when we have the function here. So the function here is f of x equals the absolute value of 3x minus 2. So we're just going to plug in each of these values here. So it says 3 times negative 2 minus 2 if I watch the x value over there in the table. So what does that mean? You're going to complete what's underneath the absolute value there first, and then we're going to do the absolute value here at the end. So you have to follow the order of operations, which is PEMDAS. There. So we have to take care of our parentheses here first. Then we take care of our exponents. Then we've got multiplication and division here next from left to right. And then we've got addition and subtraction from left to right. So in here, we've got inside the absolute value there, we've got multiplication and we've got subtractions. We have to do multiplication before we subtract. So 3 times a negative 2 there is a negative 6. And then minus 2 gives us a negative 8. And then whatever is underneath the absolute value, that whatever comes out of there has to be a positive value. So it has to be a positive 8. So negative 2, 8 is our first ordered pair there. And our next one here, we've got 3 times a negative 1 minus 2. Again, follow the order of operations. We have to take care of what's in the absolute value. It's kind of like the absolute value there is kind of like our parentheses there first. And then inside the parentheses there, or inside the absolute value there, we've got multiplication and then subtraction. So multiplying there first. So negative 3 minus 2. Negative 3 minus 2 is negative 5. Absolute value of negative 5 there is 5. All right, let's put in 0 because that's the next one we're supposed to plug in there. 3 times 0 there is 0. Minus 2 is a negative 2. Absolute value of negative 2 is 2. Whatever comes out of the absolute value has to be positive. So then the next one here, 3 times 1 minus 2. 3 times 1 there is 3. Minus 2 is 1. What's the absolute value of 1? It's 1. Whatever comes out of the absolute value has to be positive. And then our last one here, 3 times 2 minus 2. 3 times 2 there is 6. Minus 2 is 4. Absolute value of 4 is 4. So there we have our nice completed table there, given its function. So this time we have a square root, and they're telling us to plug in 0, 1, 2, 4, and 12. So let's follow that through. So we've got 2 times 0 plus 1. So again, follow your PEMDAS there. What are we supposed to do first? We're supposed to take care of whatever is underneath the square root. We're going to do that last. So we're going to take care of 2 times 0 before we take care of addition. So multiplication comes before addition. So 2 times 0 is 0. Plus 1 is 1. Square root of 1 is 1. Go ahead and plug in 1. 2 times 1 is 2. Plus 1 is 3. What's the square root of 3? That's something you probably just want to put into your calculator. So let me bring up my calculator here, and I'll show you where that is. If you've got the TI-83s or the TI-84s, there should be a nice square root button on each of your calculators, so we can get kind of a decimal approximation for that. So I'm going to do second quit just to get out of that. My square root is right above the x squared key, so I'm going to go second x squared, and I can put in 3, hit enter, and it's going to tell me it's about 1.73. I'm just going to go out 2 decimal places. So 1.73 about. Now let's plug in 2. So 2 times 2 is 4, and then plus 1 is 5. And now I can plug that into my calculator as well. So second x squared there. Whoops, nope, that's not what I wanted. Second x squared. I'm going to plug in 5. I'm going to hit enter. And it's about 2.24. So now let's plug in 4 here. We've got 2 times 4 plus 1. So we've got 8 plus 1, which gives us the square root there of 9. And the square root of 9 there is simply 3. And then we're told to plug in 12. So 2 times 12 plus 1. 2 times 12 there is 24, plus 1 is 25, and the square root of 25 there is 5. So we filled in our table. All right, so now we're on to our last learning target here. We're going to evaluate a function at a given algebraic expression or a given function here. So you have a function here, and now we're just going to substitute our values into that, whether it be an algebraic expression or whether it be a numerical value. So when it says f of -2, it's telling you here that x here is -2, and you have to plug it into each one of those values in there, into the function. So I'm going to do that. I'm going to do 3 times -2, and since x was squared there, I have to square the -2. And then I'm going to put a -2 in here for my x, and then I'm going to subtract 5. So wherever the x's were, we replace those with -2. And then again, you follow your PEMDAS. You have to take care of your parentheses first and then your exponents. So my first exponent here I have to take care of is -2 squared. What's -2 to the second power? That's -2 times -2, which is 4. So then 3 times 4 here is 12. I have to do multiplication here next. And then I've got a -2 and a -5. So now just do it from left to right here since they're both subtraction. 12 minus 2, there is 10. And 10 minus 5, there is 5. You could also just put it right into your calculator the way it is written there. I could just plug in here 3 parentheses, -2, end parentheses, squared. And then we've got a plus a -2, and then a -5. And I end up there with 5. So whichever way you like to do that. So I'm going to do another one here, complete another one. Again, they tell us to put 0 in for the x's, so it's 3 times 0 squared plus 0 minus 5. Follow the order of operations. 0 squared, there is 0. 0 times 3, there is 0. And then plus 0, and then minus 5. So we end up there with a -5. Now it's telling us to plug out an algebraic expression in there for the x's. So I'm going to take the a and plug it up there and for the x's. Same thing, 3 times a squared plus a minus 5. What's a squared? It's just a squared, so 3 times a squared is 3a squared plus a minus 5. And I don't have any like terms there to combine, so I'm just going to leave this as 3a squared plus a minus 5. My next one here is I'm supposed to substitute 1/3 in here for my x. So 3 times 1/3 squared plus 1/3 minus 5. So again, follow the order of operations. I have to square this here first. That means 1/3 times 1/3. Let me write that out. 1/3 times 1/3. So remember, you multiply your numerators, multiply your denominators inside the parentheses there. So 1/3 times 1/3 there is 1/9. And it's probably easier to put a 1 on the bottom there of the 3 there, so when I multiply my numerator and denominators there next, I can get the correct value. So here, I'm going to go ahead right here. I've got 3 over 1 times 1 over 9. I can multiply my numerator and my denominators there. So I get 3/9, and then plus 1/3, and then minus 5. I can either get a common denominator here, but I'm thinking I'm going to reduce down this 3/9 here. So 3/9 reduced there. 3 goes in 3 there once. 3 goes in a 9 there 3 times. So I have 1/3 plus 1/3 minus 5. Since I have a nice common denominator there, I can go ahead and add these two fractions together. 1/3 plus 1/3. You add your numerators and write down your common denominator. I'm going to get a common denominator over here. I'm going to multiply the numerator and denominator here by 3. So I get 2/3 minus 15/3 there. Gives me a negative 13/3. So could you put that into your calculator? Yeah, you could put that into your calculator. So let me show you how to do that. So from the get-go here, I could go 3 times 1 divided by 3 squared, and then plus 1/3, and then minus 5. So you get a negative 4.333 repeating. So you could write that as a decimal as long as you can write it as an exact solution. So negative 4.3, and then you put that repeating bar above the 3. You could also have your calculator change that into a fraction. I could hit the math frac button, and it will tell me a negative 13/3. Right, and then we have a plus b. So again, we're just going to substitute it in there. So I'm going to do 3 times a plus b squared plus a plus b, and then minus 5. I'm just substituting the a plus b in there for the x. So this a plus b squared, when it's squared like that, it's a plus b times a plus b plus a plus b minus 5. I can't do anything with those 3 terms there at the end because none of those are like terms, but I can do something with this. I can multiply this out. So just FOIL that out. So your first terms there, a times a, there is a squared. Your outer terms there, a times b, there is 1ab or ab. Your inner terms here, and when I write these down, I'm going to, since I've got 2 variables there, I've got a b and an a there. So b times a is ba. But I put them in alphabetical order, so that means it's ab. And then my last terms here would be b times b, there is b squared. And then I still have a plus a plus b minus 5. Next thing I'm going to do is distribute my 3 through here. So I get 3a squared plus 3ab plus 3ab plus 3b squared plus a plus b. Oops, I forgot a b in there. And then minus 5. All right, I'm going to combine any of my like terms. So I'm seeing I've got that 3ab plus a 3ab. Those are my like terms. So I get a 3a squared plus 6ab plus 3b squared plus a plus b minus 5. Notice I don't have any like terms, so I can't go any farther with this. So that is my solution. So let's try one more evaluate a function here. So this one here, again, we're just going to substitute the values in there. Since it's f of 1, we can put it right into our function there. So our function's right here. So we're going to take the 1 and plug it in there for our x, and a 1 and plug it in there. So we get 1 squared plus 1. What's 1 squared? 1 times 1 is 1, plus 1 is 2. So f of 1 there is simply 2. f of negative 2. So now take negative 2 and plug it in there for the x. So negative 2 squared plus a negative 2. What's a negative 2 squared? It's negative 2 times negative 2, which is 4. And plus a negative 2 is 2. So f of negative 2 is 2. What's f of x plus 1? So we're going to put x plus 1 in there for x, square it, plus x plus 1. X plus 1 squared is x plus 1 times x plus 1. So again, we're going to multiply that out. Go ahead and multiply it. So you can either use the distributive property here twice here, or you can think about pulling it out. So x times x there is x squared. X times 1 there is 1x. 1 times x there is 1x, or 1 and 1 times 1 there is 1. And then I still have my plus x plus 1. So I'm going to combine all my like terms. There's nothing to combine with x squared, so I'm going to write that out. I have a 1x plus a 1x plus a 1x gives me a 3x. And then I have this 1 and this 1 over here, and if I add them together, I get 2. So we end up there with x squared plus 3x plus 2. All right, our next one here, we have a negative a. Let's try that one out. So substituting negative a in there for our x. So it's negative a squared plus a negative a. Negative a squared, a negative a times a negative a is a positive a squared. And then I just have a minus a. Can I combine those? No, those aren't like terms. So I'm just going to leave that as a squared minus a. What about 1 over a? So remember the function is x squared plus x. So it's 1 over a squared plus 1 over a. What's 1 over a? 1 over a, you can either think about squaring both the numerator and the denominator there, or you can think of it's 1 over a times 1 over a. I'm just going to do 1 over a times 1 over a. So multiply my numerators right here and multiply my denominators right there. So 1 over a times 1 over a is 1 over a squared, and then plus 1 over a. So we can either stop there or we could get a common denominator and add them together. I'm just going to simply stop there. So now you can work on the 1-1 worksheet.